of arithmetic. Arithmetic has been around for a very, very long time, but I noticed it has some major problems in its foundations a long time ago. So I've been working on fixing the foundations of mathematics since 1983, which is a very long time to be exploring a subject that nobody else even seemed to have really noticed. So anyway, I'm just going to go through the slides reasonably quickly, so don't worry about taking notes. You'll be able to download all of these slides later on. So, from the death of arithmetic to the maths of divine India. So, India, we have a problem. Many hate or fear your maths. So, what happened? India and China used to lead the world in mathematics and be the world's leading economies. And if you look here, I've got a chart of GDP, global GDP, basically over the last 2,000 years. And if you look at the green line, you can see that India, around about the year 1, had around about a third of the world's GDP, which is absolutely remarkable. And I'm sure that very few people in India realise that you used to be such an economic superpower. You can also see in the year 1 that China was also an economic superpower, but as you can see in the chart with the green line for India and there's sort of the grey line for China, both of the countries that were leading the world in mathematics went into a long decline. And as you can see here, China has begun to pick up dramatically, and India has begun to increase, but not as rapidly as China. Now, these are some of the issues. I'm going to be sharing maybe some painful truths in a country that invented our mathematics system. And the painful truth is that Indian students have ranked second last in a global test out of 74 countries. So something's happening here, and I suspect that somehow maybe the Indian people, maybe like myself, intuitively didn't connect with Western mathematics. So maybe the reason India is underperforming is you know the mathematics is not right in your heart. And here's the statistics. This is from a PISA mathematics survey, which is a program for international student assessment. So in Tamil Nadu and Himachal Pradesh, 15% and 12% of students are ready to use their mathematics in ways that are considered fundamental for their future development. That's a very low share, when the OECD average is 75%. So you can see that when it comes to international comparisons of mathematics, these are the official statistics, and these two states were chosen by the Indian government. So imagine if they chose states that maybe weren't quite so good at mathematics, what those results might have been. Similarly, in the PISA Science Survey, in Tamil Nadu and Himachal Pradesh, only 16% and 11% of students are proficient in science to participate actively in life situations related to science and technology. The OECD average is 82%. So what I'm going to do is explore maybe how this came to be. And as you can see here, there's an article, PISA, China tops, India has fled the race. Now, why did India flee the race? Well, maybe the testing wasn't suited to India, but maybe it was a little embarrassing that India only outperformed one other country out of 74, and that was Kyrgyzstan. So if I wanted to study mathematics, I could go to Kyrgyzstan and maybe do as well as if I studied it in India, which is totally wrong. So we know that India once was a superpower in mathematics and a superpower in science, as was China, and I think what we have to do is to turn this trend around in a very big way. So this presentation talks about some of my notes on my mission to rebuild elementary mathematics from zero. So here I am sitting in the front row, and I noticed my teacher's explanation of maths was missing India's 0. And you can see that was 1968. And so I thought I'll have to fix this. So there I am, grade 2, 1968, age 7, was when I first started to get curious, or maybe it was when I first started to get confused about mathematics, if I'm to be honest. Fast forward to 1988, and here's an article where I'm quoted in the newspaper as saying, "I hope to change the way the Western world teaches maths." So this was my project I began on the 18th of March, 1983, at around about 1 p.m. So here we are, various newspaper reports about my attempt to bring together all of the pieces of the puzzle of mathematics and make sense of it. And this paper here, the first peer-reviewed paper I had published, was based on my experience as a boy in class 2 at age 7. And what I didn't know when I was 7 was that I had stumbled across the fact that Euclid's definition of multiplication was incorrectly translated, and people have been explaining mathematics incorrectly because of a bad translation since February 1570. It's mind-blowing stuff that teachers all around the world will often say multiplication is repeated addition, and they'll say that that's Euclid's definition, but it's actually a man called Henry who put in his definition instead of Euclid's. So I'm now starting to move away a little bit from the research, and I'm now starting to tour India. This is my 3rd tour of India. On this occasion, I'm visiting 6 states. So here I am with students, and here I am in another class with 550 students. And the teachers, as it happens, are also asking questions as if they were learning mathematics for the first time. And this one was just from last week. Again, this is a group of Year 7 students. So, the media has started to pick up on my research and my life devotion to restoring Indian mathematics, as you can see. You are probably in a better position to understand these newspaper articles than I am. Luckily, there is one in English. The others are in Hindi and Bangla. So, it's better to know nothing than to know what ain't so. That was Josh Billings, 1874, an American humorist. Now, in this talk, I'm going to be talking about arithmetic, the basic operations, plus, minus, multiply, and divide on the integers. So I'm talking about elementary mathematics. No rocket science here. Now, obviously, India's ancient integer logic got to us today, but how? What facts do we know? So I'm just going to review quickly the accepted history of mathematics, just in a few minutes. So India's definition of 0 as a number and integer arithmetic was embraced by the Arabic world, and you might know that in the West they're often called Hindu-Arabic numerals. So the Arabic world was instrumental in the passage of Indian arithmetic. Al-Khwarizmi wrote a book on Hindu integer arithmetic, which featured Brahmagupta's ancient laws of sign for positives and negatives. And based on what he learned from the Indians, Al-Khwarizmi then wrote a book on algebra. And we get the word algebra from one of the words in his book title, and we get the word algorithm from Al-Khwarizmi. So from the Arabic world, India's mathematical foundations made their way to North Africa, where Leonardo Pisano, also known as Fibonacci, mastered them. And then Leonardo Pisano then documented India's mathematical foundations, involving Brahmagupta's definition of 0 as a number, and thus Europe came to understand Indian arithmetic. So the transmission of India's integer arithmetic went from India in the 7th century to the Arabic world in the 9th century, and then finally into Europe in the 13th century, which is how it developed into what we teach students today. What facts do we know? 0 is defined as any number subtracted from itself, like n minus n. Negative numbers are less than 0. Negative 7 is less than negative 4. And every basic arithmetical operation on the integers is understood and has been for centuries. Euclid in his book Elements defined multiplication as repeated addition, and therefore AB is thus defined as A into itself B times. And A to the power of B is thus defined as A into itself B times. So, if that is arithmetic, Jonathan J. Crabtree welcomes you on a journey from the death of arithmetic to the birth of Podometic. So, this is not just about the death of arithmetic, but it's about the rebirth of Indian mathematics, which is going to be launched in a year's time in India with a series of free mathematics books made available to every child in India based on the correct foundations of mathematics that the world has not yet known. So what we know about arithmetic ain't so. Every previous fact is false. I gave you the conventional ideas of the broad brush history of mathematics, what happened from the travels from the 7th century India to the Western world and what we teach today. Every fact I had on those slides is false. And this presentation is to explore how India's mathematics came to be lost. So everyone is entitled to their own opinion, yet not to their own facts. So I'm like the prosecution for who murdered mathematics, and I have to make sure that I've got all of the evidence to prosecute my case. Somebody murdered mathematics, and I've been figuring out when, why, how, and who. So let's let arithmetic die and be reborn from 0. Now, extraordinary claims require extraordinary evidence. Tick. So, India's definition of 0 never made it to either the ancient Arabic world or Europe. In the Arabic world, India's 0 only came to exist as a placeholder, not as the power tool to solve simple problems like +3 minus +4, or -2 minus -4, or -4 minus +2. So, let's look at the evidence. Brahmagupta, you may be well familiar with him, famous astronomer and mathematician who wrote Brahmagupta Siddhanta in the year 628. So for this talk, Brahmagupta's laws of positives, negatives and 0 have been freshly analysed, and you can see here that with the help of Sanskritists and mathematics professors both in India and also in North America, I've analysed line by line the Sanskrit of the laws of mathematics for the laws of sign for algebra written by Brahmagupta. Now, I'll continue on, but this is where I really found gold. I've been doing my research out of ancient Greek, Latin, Sanskrit, Arabic, Hebrew, French, German, Italian, Russian, Dutch, Czech, Spanish, Mandarin, about another 5 languages, but I finally struck gold with Brahmagupta. So, I'm moving on very quickly to Brahmagupta's 5 addition laws, Sankalana. So here, you're familiar with these. Positive plus positive is positive, negative plus negative is negative, positive plus negative is the difference between the positive and the negative. When positive and negative are equal, the sum is 0. That's a very powerful one, which has been missed. And positive plus 0 is positive, negative plus 0 is positive, and 0 plus 0 is positive. And that's all bundled together in that Sanskrit verse or shloka. Why is Brahmagupta talking about adding 0 again and again and again if he didn't want us to decode how is this going to be useful in mathematics? We just teach 0 is the additive identity and we basically forget about it. But that's not necessarily the way to understand Hindu mathematics. So here on one slide are Brahmagupta's 5 addition laws, and boom, I get rid of all of those because only the first law was understood in the Arabic world. Because everything else is talking about a mix of positive and negative numbers. So let's move on to Al-Khwarizmi. I had seen that the Indians had set up 9 symbols in their universal system of numbering. So they made 9 symbols, which are these, 9, 8, 7, 6, 5, 4, 3, 2, 1, and every number is put together above 1. So Al-Khwarizmi didn't mention 0. 1 is the root of all number and is outside number. So Al-Khwarizmi didn't mention 0, and he didn't even accept that 1 was a number. Now, I'm not going to read the shaded out grey text. You can download this presentation and read that at your leisure. So let's move on to perhaps the next most influential Arabic mathematician, Al-Uqaydisi. And Al-Uqaydisi considered 0 a placeholder, but not a number. Why are the Hindi letters 9? So much for the 9 letters. 0, the aim is only to occupy the place. We multiply the letter by 0 to occupy the place and tell that there is a place and that it's empty. Now this man was really instrumental in the passage of Hindu mathematics into the Arabic world and then on, because he translated the system of the Goba dust boards, or writing the mathematics on dust and then erasing it step by step. He gave us the written form of the algorithms that we're more familiar with today. This man was very important in the passage of Hindu mathematics. It just happens that he didn't accept 0 as a number. So, 200 years after Brahmagupta, Al-Khwarizmi did not accept 1 as a number, 0 as a number, never. 300 years after Brahmagupta, Al-Uqaydisi, and I apologise for the wrong translations, I've never heard them actually spoken in the Arabic language. Al-Uqaydisi accepted India's 0 as a placeholder, yet not a number. Why? Al-Uqaydisi means the Euclidist. He was known for his skills in studying the Greek geometry of Euclid and translating it into Arabic. So around about 300 BCE, Euclid defined number as a multitude of units. So Euclid's definition of number came long before 0 and 1 were ever to be considered as numbers. Now, India defined 0 as the sum of opposing negative and positive numbers or quantities with the same multitude or magnitude. Now, if the Arabic and European writers in medieval times really understood India's 0, where are all the negative numbers in their writings? Brahmagupta defined 0 as the sum of equal negative and positive. So if the Arabic world and the Europeans in medieval time understood Indian maths, they would have written about all the negatives and positives that can sum to 0. But this is the situation, and I quote, "I have read a few dozen medieval Arabic books on arithmetic and algebra, and there is no hint of negative numbers in any of them. 0, too, was not regarded to be a number, but was merely the placeholder for an empty place in the representation of a number in Arabic, i.e. Indian, notation. All numbers in Arabic arithmetic were positive. No Arabic author, to my knowledge, ever even contemplated the existence of negative numbers." Now, if the Arabic world didn't contemplate negative numbers, you know what? That means we do not yet understand negative numbers, because it was largely through the Arabic world into North Africa, into Europe, that the transmission of India's mathematics heritage came to us. So, the maths myths that we know. India's definition of 0 as a number and integer arithmetic was not embraced by the Arabic world. Al-Khwarizmi wrote a book on Hindu integer arithmetic which did not feature Brahmagupta's ancient laws of sign for negatives and positives. based on what he learned from the Indians, Al-Khwarizmi then wrote a book on algebra? No. When we go to school, we learn arithmetic first, and then we learn algebra. And so people have put that back in the history of mathematics. They say Al-Khwarizmi wrote a book on arithmetic and then wrote a book on algebra, but no. He wrote his algebra text first, and then later on, when he started to learn about Indian mathematics, that's when he wrote his book on Hindu mathematics. So the Arabic algebra was not fully informed. And we think that the Arabic world carried India's mathematics along with the development of algebra. Only the very most basic arithmetic came for the journey. So, comparing Al-Khwarizmi's approach to Brahmagupta's, I quote, "Once again, Al-Khwarizmi differs from Brahmagupta, this time in not employing any abbreviation. Also, he avoids using negative numbers or a larger number subtracted from a smaller one, or from zero. Whereas Brahmagupta, like other Indian mathematicians before him, does not hesitate to make use of such negative numbers. It is difficult to imagine that Al-Khwarizmi, if he had read this chapter, i.e. chapter 18 of the Brahmagupta's Brahmaspecha Siddhanta, it would be difficult to imagine that Al-Khwarizmi, if he had read this chapter, would not have been able to profit by it, even if to only shorten the presentation of his work. The style of the mathematical reasoning that is at work in Al-Khwarizmi's algebra has nothing to do with what we encounter in the work of his Indian predecessors." So, Brahmagupta had everything we need today. Basically 200 years later, Al-Khwarizmi didn't have one as a number. About 300 years plus later, Al-Khwarizmi only had zero as a placeholder. So let's just move these gentlemen aside and look at Leonardo Pisano. So here we've got a quote that I made up. "I am Leonardo Pisano. I am the man most responsible for introducing India's arithmetic into Europe in the 13th century via my book Liber Abaci. As I got my Indian info from Arabic traders, I did not get to learn about India's definition of zero as a number or the rules of positives and negatives. Whoops." So here I've got a map, and it's just for illustrative purposes only, but it tells a story of the transmission of zero as a placeholder, but not as defined by Brahmagupta. So we start off in India, near Binmal, and it travels over to Baghdad, to the House of Wisdom of Al-Khwarizmi. Then it goes over to Northern Africa, where it finds its way to Leonardo Pisano, also known as Fibonacci. He takes it into Italy, and from Italy it then travels to England, and I'm skipping through hundreds of years of history there. And finally, one of the most influential people in the area of arithmetic is Robert Record. So, those unaware, zero was defined as the sum of equal positive and negative magnitudes of equal size, included Al-Khwarizmi in Iraq in the 9th century, the traders of North Africa in the 12th century, Leonardo Pisano in Italy in the 13th century, and Robert Record in England in the 16th century. And, for example, Robert Record's book on arithmetic was published for about 150 years. So that really was one of the most influential books that established how elementary mathematics was understood in England. I invented the sign equals and introduced the pre-existing sign plus to England. Yet I never knew about your zero definition, Mr. Brahmagupta, or laws of positives and negatives. So this cartoon is me. I've gained a little bit of weight. In 1478, the first book printed on maths, the Treviso Arithmetic, said numbers start at 2. So much for 0 and 1, which is all your computer needs. In the 16th century England, people used Roman numerals, and there was no Roman numeral for 0. Now, the maths at the time in the Renaissance and after was based on ancient Greek maths, which did not have 0 1, or negative numbers. So, the false idea that negative quantities are less than 0, rather than opposite in nature to positive quantities, emerged in Michael Stifel's Arithmetica Integra of 1544 in a section titled De Sinis Additorum and Subtractorum and De Numeris Absurdis. Basically, the signs of addition and subtraction and absurd numbers. So Michael Stifel said negative numbers were below 0, which is below nothing. Infra 0 id est infra nil, and negative numbers were absurd, numeri absurdi. Brahmagupta was an astronomer. He used positive quantities and negative quantities, and he had numbers to measure the opposing quantities because he was an astronomer and he was a scientist. And here we are, almost 1,000 years after Aryabhata, and people are saying negative numbers are absurd, but they're essential to physics. To make sense of numbers that count or measure negative quantities, i.e. negative numbers, all we need to do is to drop the nonsense notation that negative quantities are less than 0. Then, negative numbers simply count or measure opposite quantities or forces which are always greater than 0. Perhaps you might recall Newton's third law, which states for every action there's an equal and opposite reaction. Bingo. Newton's laws of motion are consistent with Brahmagupta's laws of quantitative mathematics, which are also consistent with quantum physics. Think about it. 3 negative electrons and 3 positive protons, that should be positrons, are equal and opposite and cancel each other out to sum to 0. So as maths books got published in the English language, without 0 or 1 in algorithmic definitions or as numbers, they were exported to England's settlements and colonies, such as New England, which became America. So as the English language spread, so too did major misunderstandings of India's mathematical foundations. It's like there was a virus that was established and it got spread. England had the printing press, and the rest is unfortunately a negative history of the evolution of mathematics. So in the year 628, Brahmagupta gave solutions to equations we'd write today as x squared minus 92y squared equals 1 and ax squared plus bx plus c equals 0. However, the first person to say 1 was a number in the West was Simon Stevin in 1585, almost 1,000 years after Brahmagupta. The West is basically 1,000 years behind, and when they're starting to try and catch up, they've got everything wrong. Not everything, a lot. So where is 0 today? There's your typical keyboard, and if you look hard, you'll see it's a placeholder 0. 0 is still on the keyboard used as a placeholder. Type 90, 90. Type 20, 20. It belongs at the start because it's the origin of number and mathematics, but even our keyboard is giving up. So the mathematical foundations of India are true and correct and logical and consistent and very easy to understand. Children find no problems whatsoever with lessons to do with negative into negative or negative by negative. The foundations that emerged out of the British Empire through its period of colonisation around the world, those foundations were fatally flawed. So, what I've done is I've assessed the world's pedagogical evolution from the time of Brahmagupta to now. If you look across the top row, I've just got examples of addition, and this is just, again, it's just integer arithmetic. The second row, it's got examples of subtraction. The third row has got examples of multiplication, and the fourth row has got examples of division. And what I've done, based on my analysis of Indian mathematics versus what's taught around the world now that came out of the West, is I've colour-coded all of the combinations of those 4 operations with both positive and negative. So if it's got a green colour, it's passed. It's adequate in our education systems around the world. If it's got a yellow cell, that means it's broken, it fails, it is fundamentally flawed and broken. And you can even see that there's one cell there where people don't even try to explain division of a positive number by a negative divisor. All they do for hundreds of years is they ignore the division and they convert it into a multiplication problem. Okay, so Podometic will soon replace arithmetic in a year's time. As I mentioned before, the plan is to give every child in India a set of free mathematics books, digital downloads, that will take this mathematics matrix with all its problems in it, and everything will become green. Everything becomes so simple, 12-year-old children will be able to understand how integer arithmetic works to their mathematics teachers once they read these cartoon books. So, speaking of cartoons, hey kids, play with me and I'll make maths fun, fast and free to learn. From class 1 on, it all connects with the laws of physics as well. So, this is an example of some pages from the ebooks. There's Podo the puppy popping her head up, and she says, separate or all together, all my bricks and holes give me 0. So I'm Podo the puppy. All my maths adventures are being brought to life by AFX Animation in Kolkata. And there's the website address. So I've chosen a strategic partner in India for this project. This is an Indian project about the rebirth of mathematics from 0. Now, the hard work has been done. India can update its maths and prosper, or let this major maths education advantage pass by. I hope that doesn't happen. Because what we've got to do is we've really got to think. So here, a long time ago, I got some media coverage because, well, people thought I was good at thinking and using my brain. There's the brain. We've got to start using all sides of the brain, all different modes of thinking as we educate our children. No more dry black and white textbooks. We're going to start with Podometic to involve imagination, colour, song, all sorts of things, and that's how the brain wants us to learn. So that's the creative side, the creation side, creativity. We've got to bring that into the mathematics education. So there's a sign that you're probably very familiar with. There's an image which is very, very upsetting. It's upsetting to me. I can't imagine how upsetting it is to the people of India to be going through such a period of drought as we enter an age of climate crisis. So big problems demand that we think bigger. Where is the courage? Is there going to be courage in India to fundamentally fix the huge problems that your country is in dire need of fixing? Well, that's an open question. But why is it so important that we fix mathematics? Because mathematics is the platform upon which all of the solutions of India's problems in the future are going to be built. So whether it's science, technology, engineering or medicine, it's mathematics which is going to help India overcome its problems and enter in a new golden age of prosperity and spirituality and happiness. So, I'm going to close off in a few slides. So I think I've actually done pretty well with my time. I've spoken more quickly than I usually do. So here's a poem. India's teachers so seldom know the trees of knowledge from seeds they sow. Past lives forgotten and the future a mystery, making lives count, their deeds have made history. So make your life count with love as your measure, then kids will climb trees with views they will treasure. So thank you. And to those people who are watching on YouTube or on Facebook, if you care, please share. That's the web address. Prime Minister Narendra Modi, if you ever get to see this video presentation, I hope that you share it, that you embrace the vision of an Indian renaissance on Indian mathematics, I can assure you I will do whatever I can to work with your Ministry of Human Development and Educational Specialists. I'm here at your service, Mr. Modi, so please, 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 let's explore how we can work together. Thank you very much.